Hello and welcome to this lesson about geometry word problems. The learning target for this video is solving word problems that are based on geometry. So let's talk about how this all works. Essentially what we're going to do is we're going to take some algebra skills, solving equations, plus some geo vocab, and make problems out of these. And so once we understand what we're really doing, what we need are the algebra skills of being able to solve equations, where we're going to have to combine some like terms, maybe distribute through some parentheses, or something like that. And then we also have to understand some basic geometry vocab. If we can do that, and we bring these together, we can solve these word problems and we can break them down, even though they're going to seem really intimidating and nasty. So let's talk about some of that vocab that you need to know. So there's a couple of different variations of this, and this doesn't include all of them that are out there, but the ones I'm going to choose to focus on, we're going to do stuff with angles. And so you have to know a couple of key terms. And so one of those is going to be complementary. And what that means is that they add up to 90 degrees. The second term, supplementary, and that means they add up to 180 degrees. And so all you have to know is the association: complementary, 90 degrees, supplementary, 180 degrees. Then what we'll do is use our placeholder trick, where essentially the format for this is you go placeholder 1, placeholder 2 is equal to, and then it's either going to be 90 degrees or 180 degrees. And so it's going to be very similar to like the number riddles, where you have two angles. One of them is x, the other one is going to be some sort of expression of x, and then you have it set equal to 90 or 180. And so just to kind of visually draw this out for you, complementary would look like that. Again, this might be x, maybe this is 2x. Supplementary would look something like this. Let's say this is like 2x plus 10, and then this one is x. So there's the visual for it, but what again it breaks down to is just using these placeholders, setting it equal to 90 or 180. The third type of angle thing we might run into are triangle angles. And keep in mind that triangles have to add up to 180 degrees as well. And so what that's going to do with our placeholder thing is we now need 3 placeholders set equal to 180. Something you might see a lot of, because it's really easy to write a word problem on this, is something called an isosceles triangle. So isosceles triangle. Now, this is another geometry concept that you're going to need to know, an isosceles triangle. That is a triangle that looks something like this or like this. And the idea is that these sides are the same. They're congruent. These sides are the same and congruent. These angles are also the same and congruent. And so there's a bunch of ways we can set this up. We could do perimeter problems, so maybe where we have to add up the 3 sides together, but keep in mind that 2 of them are going to be congruent. You may have an angle problem where it still has to add up to 180 degrees, but maybe, we'll call this one x, and then however it's set up in the problem, let's just say that this is, 2x plus 5. So you'd go x, 2x plus 5, 2x plus 5. Or whatever it might be. So those are some properties of isosceles triangles. The other thing that you have to be familiar with, and so this is no longer angle, but now this is going to be perimeter. And so perimeter is just the length around something. And the biggest mistake I see a lot of students making is forgetting that with a rectangle, the perimeter is equal to 2L plus 2W, or you could say it's 2 times the quantity L plus W. And so a lot of students tend to forget that you have to have all 4 of these sides, so 1, 2, 3, 4, and they only add those 2, which causes some problems. And again, you might have to do a perimeter for a triangle, and if that's the case, you just add the three sides together. And again, the key thing we'll have to do is use our placeholder idea, or for perimeter, we'll just use some of these formulas. So those are some of the basics that you're going to need to be familiar with. Now let's apply them through some examples. So this first example, one of two supplementary angles is 5 times as large as the other. Find the measure of each angle. So first thing, I see supplementary, so what that means is I'm going to go 2 placeholders equals 180 degrees. I'm going to read the problem a little more, and I'm going to see that I have something that kind of says something about, or talks about the relationship between the two angles. One of them I know absolutely nothing about, so that will be x. The other one is 5 times as large. That means it's going to be 5x. And so if we kind of draw this out, supplementary angles mean a straight line. We have 5x and x. And again, we have to add this to be 180 degrees. Well, we've now set up the structure for the equation, so we can combine our like terms. 6x equals 180, divide by 6, x equals 30. Now, again, we have to make sure that we're answering the question that is posed, or solving the problem that is posed. Find the measure of each angle. Well, we found this one. That's 30 degrees. So 30 degrees, and then we have to figure out what this one is. Well, that's 30 times 5, 150 degrees. So there's our final answer there. All right, now let's look at another one. Let's look at one that's maybe a little more complicated. Find two complementary angles if the larger is 10 less than 3 times the other one. Oh, it got real here. Okay, now let's draw it out. Complementary angles. I'm just going to kind of draw it here. Doesn't matter if it's to scale. So let's see here. Complementary, so we have the 90-degree thing going on here. The larger is 10 less than 3 times the other. So one of these is going to be x. The other one, 10 less than 3 times the other. Now be careful. That's 3x minus 10, not the other way around. So now that I've kind of, drawn it out, I'll use my placeholders. Two angles have to add up to be 90 degrees. So I have x, 3x minus 10. Now I can combine them. 4x minus 10 is equal to 90 degrees. Add 10 to both sides. 4x equals 100. Divide by 4, x equals 25. Now remember, I'm not just solving for x here. There's some context. I need to find two complementary angles. One of them is 25 degrees. The other one I can apply to this expression here, or I could take 25 and subtract it from 90 to get 65. So you got a couple of options there. So here, 65 degrees. Box it, walk away. So those are some angles. Now let's get into some of the perimeter stuff, or the isosceles triangle stuff and whatnot, because that can get really interesting and make things pretty complicated. All right, there we go. I think that's fixed now. All right, so here, the perimeter of a rectangle is 92 centimeters. Find the length and width if the width is 4 more than twice the length. So I'm going to recommend you draw a picture. Okay, again, the scaling doesn't matter, but having some sort of visual is huge. Helps us out a lot. So we know that the perimeter is equal to 92. I'm also off to the side. I'm going to write P equals, and then here I'm going to go with 2L plus W. I think it's going to make life a little easier for us. Let's write it like that. Okay, find the length and width if the width is 4 more than twice the length. So here's the thing. We don't know anything about the length. So that's going to be our variable. Our width here is equal to 4 more than twice the length. So that's going to be 2L plus 4. Now, what I'm going to do is take these two things and plug them into here. Well, I kind of drew the arrows backwards there. Let me undo that. All right. This L will go to L, but then the width, that expression of L will go there. So our thing is, the problem, we can't solve this yet until we only have one variable. We have a value for P. So we'll put 92 in for P is equal to 2, and then L is still L, plus, but instead of saying W now, I'm going to say 2L plus 4. Now here we have to distribute. So make sure you take your time and you distribute to all three components. So, or I guess if we wanted to, we could also divide by 2, but I've already kind of committed to distributing, so I'm going to do that. 92 is equal to 2L plus 4L plus 8. So I'm going to continue my work off here to the right. Actually, let me lower this thing, give myself some more space. All right, so we have 6L plus 8 equals 92. I like to have my variables on the left, number on the right. All right, do some subtraction, subtract 8. 6L is equal to 84. Divide both sides by 6, and L is equal to 14. Now again, I haven't answered my actual question yet. Oh, why is this being weird? That's so odd. Okay. All right, it is what it is. Okay, I need to find both the length and the width. So I've found what L is. Now I can take this value and I can plug it back in for W. So I'll go 2 times 14 plus 4, and that's going to equal 28 plus 4, which is 32. So W is equal to 32, length is equal to 14. Okay, last one. Let's end with a good one. Find the angle measures of an isosceles triangle if the two congruent angles are each 40 less than half the other. Holy shnikes, got real. Okay, so I'm going to draw an isosceles triangle. Again, it might not look like this in reality, but I just need some sort of visual image to wrap my mind around this. So let's see here. The two congruent angles, that's going to be these two angles right here, are each 40 less than half the other. So what I'm getting from that is I don't know anything about this angle right here. So that means that this angle has to be X. Now I need to write an expression for 40 less than half the other. That's going to give me 1/2 X minus 40 and 1/2 X minus 40. Now I have a triangle problem and angle measures. So that means I'm going to have to set up 3 placeholders and set it equal to 180. I'll put X right there, and then I have to write 1/2 X plus, oh no, minus 40, not plus. Oops, excuse me. Let me erase that. Okay, minus 40, 1/2 X minus 40. Now I have to combine my like terms. Fortunately, these two 1/2s will play well together, and so that's going to give me X plus X minus, and I'll combine my two 40s, which will give me negative 80 equals 180. So I have 2X minus 80 is equal to 180. Now I need to add 80 to both sides. So 2X will equal 260. And finally, divide both sides by 2. X equals 130. So, let's see, I'll use red. This angle right here is 130 degrees. Now to find the other angle, I need to take 130, times it by 1/2, or divide it by 2, and then subtract 40. And so 130 divided by 2 is 65, minus 40 means I'll get 25. So my 3 angle measures are going to be 25 degrees, 25 degrees, and I know that both these are 25 because these are the same, or have the same measure, and 130 degrees. All right, I know that's a lot to take in, but with practice, it becomes easier. But the main thing is, like I said at the beginning, we have to know our vocab, and it really boils down to just continuing to use this placeholder tool. So good luck with your homework or practice, and let me know if you have any questions.